Just okay. Let's hope that... Oh, YouTube appears to be working now on at least one of the channels. Okay, so if I do this, switch account, videos, go to my channel. Okay, so I am live on YouTube as well. And what are we doing? That sounds like my wife is coming down to say something. No. No, she's starting laundry. That's good. Can you hear laundry in the background there, Rajat? No? Okay, good. That's good. So let me see if my Zoom... I have a Zoom meeting. We are... oh, we're still 2 minutes away from our special guest's expected appearance. So... Tonight's guest is Amy Miller, and she is a technical recruiter with 20 years experience. Who she has a really great YouTube channel actually. While we are here, let's see if I click on this, and we'll go here. No thanks. If we look at this, like she's just got like dozens and dozens of videos with really interesting topics for somebody who is looking for a job, and so we're really excited about that, about getting the chance to chat with her. Let's see, put that down. How has your week been, Rajat? Has anything happened? I see you're definitely super active on LinkedIn. So have you had any interviews or anything yet? Or tell me all about how things are going. I wonder, can I move chat onto... I can actually move chat onto screen so I can look at you this way. We'll see what's going on. And I am in the meeting. I should open Twitch to see if there's anybody else coming. So this is what Amy's going to see. Oh, here it is. We've got something pretty good work-wise. Met our sprint goal for this week. I don't know what you do, come to think of it. Learning new things from front-end masters, not really looking as a... Oh, okay, so you're 4 months into your new... Yeah, and so that's... I'm in the process of writing an article that I'm going to post on DevTO about this whole professional development journey thing that we've been working on. Because anyway, it's actually the thing that we talked about in week 2, where we talked about how do you build a professional development plan, and why would you build a professional development plan, and all of that kind of stuff. So I've been writing an article to post on that, to talk about scheduling, just like we said, schedule the professional development, and that kind of thing. So what else? Let's go on Twitch and see if Pebs has shown up or any of the other regulars. Obviously, we're not going to start until Amy gets here anyways, but I'm not sure. I think these two that are here. Oh, Pebs! Hooray! How about your week? How has it been? Yay! We have Glenn. There we go. We're currently just waiting on Amy to show up. Hopefully she remembers. I did just send her the links, so Sunshine, not much studying. Well, that's okay. That's okay. It is about balance, and it is about doing it on your schedule as opposed to mine, right? Because this is a volunteer session. What is it that you do, Pebs? Where are you? What are you programming in? While we're waiting. We're waiting for our guest. Oh. New messages. Right. Yeah. See, so this is actually really useful for me because I don't just have to study on Tuesday. I have to study on like Saturday and Sunday nights while I'm getting ready for this. And so yeah, I figure Amy's on her way, mostly backend.net. First, Gatsby site. Tell us about Gatsby. What's interesting or what stands out for you about Gatsby, and is that something that others should learn? So I'm just checking my email to see if Amy gets back to me at all, or oh, that's my phone was going ding. Maybe that's somebody met. Full static. Oh, okay. So that is really interesting. I know that we actually have some team members at my old employer who are super, super into... I'm just turning the volume down on all of my device things so I don't get dings in the middle of this. But we have a team that's really interested in engaging in that whole sort of static website thing because the cost of the hosting is so much lower. And I guess one of the other things that you get out of it that's really exciting is the speed of transmission of the website. So you have that sort of just your Lighthouse scores are so much better because there's no processing time on the server. Anyways, so all sorts of stuff. I guess what we can do, I did have a backup plan in case Amy, in case honestly, if she doesn't show up, this is probably on me for not being great about sending the invite. I sent it way too late, and so quite honestly, this one might be on me, and so I would not falter for that. But I did have a backup plan in case this doesn't go through. And as we've been looking, the title of this is wrong, but because one of the things that I was talking about with one of the others who shows up with a coworker, and something that seems to be going on really frequently for people going through the tech interview process is they get in there and they freeze up and they don't know what's going on. And so I'm gonna leave the Zoom open in case she does stop by. But in this case, there are a number of demo coding interviews available online. And so what you can get from watching a handful of these, and in fact, Clement Mihalescu, his website, Algo Expert, you can actually pay their engineers to run you through practice interviews so that you're prepared for this. Another way to get practice interviews is to actually go on the interviews, and so it's not really exclusively required that you pay somebody for this, because realistically, going for the interview is the practice in itself. But I thought watching this one together would be really interesting. I've actually already watched a couple of these myself and most of this one, but this gives you a sense of a Google interview. Before we dive into that one, I've also only just discovered this one called Pramp, and from what I have seen, it mirrors the interviews that I've been on in the COVID universe a lot more closely, because it is not actually coding in a whiteboard environment, they do coding in a Google Doc in this one. This one you're actually coding in a hacker rank type system. And so let's go and let's watch this.
Or an Android phone, and you were to look at your keypad on your phone, you would likely see something.
Let me back that up. That's not quite the start.
I think I am. Okay, David. So are you ready to start the interview?
And we can do this at.
All right, great. So I'm going to press start on the 45-minute timer now, and let's begin. Okay. So if you were to take out your phone right now, either an iPhone or an Android phone, and you were to look at your keypad on your phone, you would likely see something like this. You would likely see something like this, where you've got the numbers or the digits, 1, 2, 3, all the way to 9. But you would see, like, on the digits, you would see letters, right? So, like, under the 2, you would likely see ABC. Under the 3, you would likely see DEF. And this is something that was, like, really common in old phones. They still have it in modern phones, but it was really common in old phones. And the reason it was common is because it allowed you to have phone numbers that kind of read like English. So I don't know if you've ever heard of the company, like 1-800-Flowers. I'll copy paste it here. 1-800-Flowers. It's the name of the company, but it's also a phone number. And this phone number is actually...
Sounds a bit low.
Here. This phone number is actually 1-800-356-9377.
Let me see. I'm going to pause this. I'm going to go to my audio setup here, and desktop audio. I'm going to try doing something here where we actually get audio input capture. We'll call this. I think one of the problems is here we go. No, that's just doubling my voice. That's not right. Okay, sorry. I'm trying to be really quiet because I have to do audio and what's going right now. Oh my God, this is the worst. Okay. Okay, I'm just gonna point the mic at the television and hope that works out, because I think that's what's actually going on. Here, let's do that. I'm gonna play this again.
Yeah, that makes sense to me, I think. Yeah. So the point that I'm trying to get across here is that if you've got a keypad like this with digits, numbers, phone numbers can represent different words. I'll give you one more example. Like this phone number here can represent either Clement or Clemdot, okay, or any other, like there are a bunch of other combinations of words. Now, I want you to write an algorithm or a function that is going to take two inputs. It's going to take a phone number, which is going to be a stringified phone number, as well as a list of words, okay? So I'll give you a sample input right now. Sample input would be these two things. You've got a phone number and you've got a list of words, and I want your algorithm to determine which of the words in this list of words are contained in this phone numbers. Kind of like the word flowers here is contained in this phone number. And so for this particular input, you would return something like this, because these, I'll put output here, because these words here happen to be in this phone number.
So I'm looking for ones that occur anywhere in the phone number, right?
Anywhere in the phone number.
Any substring, like any continuous range?
Yes, continuous is the key word there.
I see.
Whether you're building dynamic network models or forecasting real-world behavior, Neo4j's new
Interesting. Okay, so I guess maybe first it might be helpful for me to do some simplifications.
Okay.
Of the problem a bit. So yeah. Okay. So for these words, if we just want to see if some word corresponds to like some number, it's probably easier if I replace each letter with whatever number it would correspond to, right? So in the first instance, like 366 could be a bunch of things, but it might be easier, like if I'm looking for foo, for instance, foo would be, well, it'd be 366. So instead of looking for these words, it might be easier for each word I have, so like for foo, I could turn it into like 366.
Yep.
Now I want to see, does 366 occur anywhere in the, like as any substring in this? So that might be helpful.
Okay.
And then I can do this for each word. So for each word in the order size of input, then I can look through each of those. Yeah, so on one hand, it seems like maybe it's possible to do some autocrossic sort of thing here, but that might be a bit unnecessary. I guess for like one question that
Okay, so I'm going to stop right there. The first thing that they say about doing... Let me move this in so I'm talking. So the first thing they say about doing these interviews is you should go through this phase of talking through what's going on. And don't get to typing right away. Just talk about how you're going to solve it. And so this is a really good example of that. Also important to note that this guy is he's a very high-end engineer. He does competitive coding, which is a thing, apparently. And I don't know what autocrossic is, and I mean, that's kind of intimidating. So before I start up again, I should mention that the other one that I didn't pick to start with was one that's a quote-unquote normal engineer who is not a, super crazy high-end Facebook type guy. So
I want to ask is the phone number any specific length? Is the phone number might be like really, really long, or can I assume the phone number is just like the length of a normal phone number, like 7 digits or something?
You can say the phone number can be of any length, so it's effectively like any continuous amount of digits. But don't worry too much about the fact that it might be past some gigantic number. So I guess my point is, it's not necessarily 7 numbers. It could be like 15 numbers or something like that.
Sure.
But don't worry about too large of inputs.
So like one solution path that I can go down would be something where the final runtime would be...
Sorry, and the thing that he's doing right there, he's going through and he's clarifying the question. He's talking about what edge cases do I have to worry about, and how could the input possibly change? And these are the skills that they're looking for. This is really interesting, where he's already talking about his big O notation for the thing that he's about to solve. And so these are really important points to look at in terms of when you are going into your coding interview, what kind of coder are you going to present yourself as? And if you are doing this, you kind of want to emulate this sort of thing. In a couple of weeks, there's a lot more system design samples online, and we'll be going through another one of these in terms of going through a system design interview, which is also really which is also really interesting and useful, and definitely helped me in the process that I just went through. So here.
The order phone number length squared. That would be one solution path that I might be able to use. And the idea behind that would be I can find some representation for every continuous range of this phone number. So if you consider every start point and every end point of the phone number, you'll have some big value. But what I can think about is like I can compress that value into some other value where if some word is also equal to that value, there's a very good chance those are the same. And that's a thing called string hatching. So I guess I'll get there if this would be a solution that would be helpful. But still the length one, GTH, there you go. So yeah, so that's one thing that I could try. Another thing might be if all of my words are short, if I know all of my words are like some relatively small length, then I can only look at the substrings that are of that length. So if I know maybe all of the words aren't super long, then I can check only substrings of that length. So that would be order like number of different word lengths times the length of the phone number.
So let's assume that for the words, they are of any length between 1, so they can't be empty, between 1 and the length of the phone number.
Okay, so yes, that's a good thing to keep in mind. So I guess that means this solution wouldn't be very helpful at all because it would pretty much just be the same as this top solution. All right, so then, yeah, I guess it might be interesting to consider what if we tried some autocrossic here?
What if you could control the web with your mind? What if telekinesis?
So
Now, I don't know Aho Crossic, but I do know that last week we were talking about tries, which are about a data structure built around characters and finding words in it. And so I don't know, I find myself wondering if that's going to come up, but I don't know.
basically, we can imagine, let's say I have some try, basically, and the try consists of all of these words.
Okay.
Then what I want to find out, basically, is for, like for each prefix, I want to see for some suffix of that prefix, what's like the longest suffix that exists as some path in the try.
Okay.
And then that'll have like a link back to, well, the details I guess are a little complicated, but we'll be able to see like where this goes in the try, and then based on like where that goes, we can take several steps up and like repeatedly look at that, and then we can mark all of the different words that we see there. So yeah, so I guess basically the idea is like one thing that I might consider for the solution path is maybe I'll build some try of all of the words, and then after that I'll have like some links for each node in the try. Or I guess there are only 10 digits, right? So I want 26 links, so 10 links. For like which try node you reach after each step, or after like reading every next possible input.
And I guess, David, just to cut you off here, when you say you're going to have a try of all the words, will you be putting the words in the try as strings, so this current format, or as digit strings?
I'll do it as digit strings. So basically, I'll convert all of these words into digit strings, and then at the end, in order to validate some, yeah. At the end, I'll have just like a bunch of digit strings, and then at the end, I can just say if some word matches, I can just check does that digit string match as well.
Gotcha. Okay.
Yeah. Okay. So maybe it might be helpful for me to draw an example for myself, just to kind of remind, because it's been a while since I've coded Aho Crossic myself.
Okay. By the way, I'm not sure what that is. So if you want to just explain to me what the Aho Classic is.
Yeah. Okay.
So
So
I understand what you said with the try, but I'm not sure what that like word is or name for something is.
okay. Yeah. So like well, I can explain the general idea. I can definitely, so like if the solution path you're looking for is n squared, I can definitely go down the n squared route. The thing with that is that route is completely different from the linear time route that I would be considering here. So like going down that route, I guess might be helpful if that's what you're looking for. But if you're looking for something linear, that like this is completely unrelated. But the idea for Aho Crossic is that you've got like some try. So maybe let's have some words. Maybe we have like bat. We have the word at. Maybe we have att. Or like AAT, for instance. So
Sure.
the try for that would look like you have an A, then you have T, but you also have, it's kind of confusing because these are like the letters I'm drawing are really the edges, so you've got like this is a node here.
Yep.
And then, yeah, I'm sure you know what I mean by this. But
Yeah, this is just helpful
then
to
you have
just
T.
visualize it. Okay. Yeah.
Sure, yeah. Okay, so this is the ATT. I'll bold this. I guess I'll bold and underline it because that means that's the end of some node. It's also the end of some other node. And then that adds these two words. We also have AAT. So in code, these would be ordered, but just for simplicity, I will make them unordered.
Sure.
And this is a key.
Okay.
And then we also have that.
The other thing I've got to say about this is this makes me so nervous. I don't know how you feel about this, but like there's 45 minutes on the clock right now, and he's taken time to draw this stuff up. And part of that is making me feel super anxious, but also part of that is good advice to take your time. Again, every one of the interviews that I've done in the last couple of months, I've gone into writing code right away. And this is a really good example of taking your time to talk about the solutions that you can come up with and trying to solve for that before you jump in. And I think that probably makes a pretty big difference in terms of how you are scored at the end of an interview. So I'm going to pull up Ben Awad.
So this is kind of what the try would look like. Now, the idea with ahoprosik is when we have some of these, like if we have some big string, okay, so I guess this example is with letters, but the real example will be with digits instead of letters, but I guess it's not
That's fine.
too different.
Yeah.
So if we're looking through some string that looks like this, maybe, I guess maybe, yeah, let's say we're looking through that string. Then the idea is we're going to consider every possible prefix. So we'll consider the prefix A, then we'll consider the prefix AT, then we'll consider ATB, we'll keep going from there.
Yeah.
And for each prefix, we want as much as possible of that prefix to be, sorry, there's a motorcycle, to be in this try as possible.
Yeah.
So in this case, let's say we're looking at just AT with the second prefix. We can follow that down the try and we'll get to this A and then get to this.
So you want to be a
Yeah.
software
So that
engineer.
would be a prefix of
What's
A. Then when we see this following B, we can't actually take a B from this T.
Yeah.
So we need to follow whatever the failure link is from this T to the next thing that has a B. So in this case, if we try going up, or we'll try looking at the suffix like TB.
Oh, sorry,
If
everybody.
TB exists somewhere in this try, then we'll follow the TB. In this case, we don't have a TB, we can't do TB, so we just have to look at just the B. So we try just the B from the original, and we get to just this node. So then after reading the B, we would be at this node here.
Right.
Then we would try to read the A. Since we were at this node, we follow the A link, and now we get here. So now we're here after reading the A. Then we read this T and we put this node here. So
Yeah.
the idea is that for each node in this try, we want to say if we can't reach one of the nodes that we're looking for, we want to see we're going to go back up to some other node, and then we want to see if we go up to this node, like how far do we have to go up so that we're at some suffix of ourselves? Like what is the early, like the best thing in the try is some suffix of this. In this case, we have ATT. We want something that would be a suffix of it would be TT, so that doesn't really exist in the graph. Let me look at a better example. So if we're at BAT, if we read in this BAT and then we read another T,
Yeah.
then when we do this, first after we read the BAT, we'd be here. Then when we read the second T, we'd be like, okay, well, there isn't actually an outgoing edge labeled T here, so we have to find the last time that exists.
Yeah.
We have to find the earliest fail link for this. So this would be the suffix AT. And AT does exist in the try. It's this one here.
Gotcha.
So we would jump to this, and now we're like, okay, but now we can take the T link, so you take this link here, and then you end up at this node. That basically tells you if you take a bunch of steps, you want to know, like, which try nodes do you hit, basically.
Interesting. And so this is how you are able to kind of optimally, like with your example of BATT, when you get to this T here, like you said, you don't see the second T. The fact that you're somehow able to jump back to this AT up here, and then you get to the ATT, this is sort of like the optimal
You
aspect
just kind
of.
of broke up for a bit.
Oh, sorry, can you hear me?
I can now, yeah.
Yeah. So
Until, like, yeah, until you said jump back was the last thing I heard.
yeah. So I was just saying, like, the fact that you can quickly jump back to this AT up here is what allows like the optimal aspect of what you're describing, right?
Yeah, that allows, in order one, I can figure out if I'm at this node and I read a T, which node will I be at in the next step.
Gotcha. Okay. Yep.
So the idea is there's a really common algorithm that can, or I guess it's not common, but there exists an algorithm to build this thing. Basically, you build a try, and then on top of building the try, you do something else. And to be honest, I don't totally remember that, so I'll have to figure that out live, and that'll be, I guess, fun to watch me do. But in addition to that, once you have this thing built, then we can find all of the nodes that we visit in the try across reading the entire phone number.
Right.
So we'll read the entire phone number, we have all of these nodes in the try. Then we can do like a DFS from all of these nodes in the try to figure out which nodes are actually reachable. And for each one of these nodes, you can follow the node or the failure link.
You would remember from last week that a DFS is a depth first search, right? So
For that node. Those are all fine.
Okay.
And then, yeah, so now we have all of the nodes in the try that are reachable across any substring of this phone number. And now for each of these words, we can just say, the word corresponds to some node in the try. Was that reachable or not? So that'll just give us our answer.
So do you mind, David, writing out just very briefly, like, you know, like, I don't know, maybe a bulleted list or something of the steps that you're going to go through from start to finish?
Sure, yeah, that's a good idea for sure. It's probably helpful for me as well.
Whether you're building dynamic network models or forecasting real-world behavior, Neo4j's new
So it's right under the output section. Yeah.
Yep.
So the first thing I'm going to do is build the try. Then, as I build the try, I guess this needs to be at the same time, if I remember how to press it correctly, I need to calculate the failure links for each node in the try. So these two need to kind of happen in the same path, I think. Or maybe not, maybe this is just a second. Yeah, I'll just do this 1 second. So then once I have this try, then I'm going to walk through the phone number, keeping track of which node in this try I'm at each position. Like at each digit in the phone number.
Okay.
So that'll just use the failure links to find the next one in constant time. And then finally, once I have that, like this will tell me which nodes are reachable, like which nodes in the try are reachable. And then I want to do a BFS on the like directed graph of the failure tree.
Oh,
so now I want to do a
talking.
BFS from all nodes that I was at.
That's right. Yeah, there is no time.
By doing that, once I've looked through all of these, as I do this BFS along failure edges, then I can see this will tell me all nodes, all try nodes that are some substring of the phone number.
Gotcha.
And then like once I have that,
I personally think the hardest part about this is he's solving an algorithm that is so far over my head that I'm just thinking, this is like both learning the algorithm at the same time as learning how to do the interview. And I feel like I would feel so much less stressed about watching this happen if it was an algorithm that I kind of like had any clue of how to solve on my own, right? And so maybe I picked the Facebook engineer first because it was a shorter session, and I actually thought Amy was going to be here, and so I thought that we would be having to, yeah, right. I mean, it's so hard to get, but you know, like Rajat's saying, it's the way that he's going through the solution. This is the thing that we have to emulate when we get into our code interviews. I think I'm going to do... I actually have... so that's another really good point, is this is the reason that we have run the algorithms. Sit there, go on to Leet Code, and practice algorithms. Because one of the advantages that this guy has, and I should get his name, so I'm talking about him by name, is Second Thread. So he actually has a YouTube channel. So maybe we...
good morning, everybody.
Oh, maybe this is really good. I'm going to subscribe to him and check him out later. But one of the really important things to know is this isn't that he's just so overwhelmingly good at this stuff that he instantly knows what an Ahu Crossic is, and that sounds like the song they sing in The Grinch Who Stole Christmas, right? Like it's this isn't because he's so much better at everything. No, this guy is a competitive coder who writes algorithms against other people for points, right? Like it would be like, I don't know, it'd be like trying to win a round of golf against Tiger Woods. Like it's just, anyways, we'll keep going.
Through each word, I guess, and then check if it was visible, and then just print out the answer there.
Okay. And just one quick question. So this thing that you keep calling Ahu Classic, is that the algorithm to build the tree, or is that...
That is the part that does this part right here. Calculates the failure links and then where you go after each step. So
Gotcha.
Usually I wouldn't write this myself because I don't have it memorized because it's just like a thing on paper. So
Right.
I would always just reference that. But yeah, that would do this part for me. It's like it was like a research paper that maybe people named Aho and Crossic invented.
Gotcha.
So yeah, so that's what this part does. But once I have that part, then the rest of it is all pretty straightforward. So Aho Crossic just does this part to answer the question.
Understood. And so, for the sake of this interview, though, how about we do this? Let's skip this part for a second. Let's skip the part that you just said, is going to be difficult for you to re-implement. Let's assume that we have that at that point, and you can tell me, what whatever the structure looks like, and you can just implement this part.
Sure. Okay, sounds good. Yeah. So I'll just like I guess write a blank method for it. And then if this were like a coding contest for like a real job, then I would look it up and just paste that part in this method. If that works.
Yeah.
So yeah. So is it alright if I start coding then?
Go ahead.
Sounds good. So like this would all be inside some class, but I won't actually write the class because it'll kind of use up my init.
Again, based on my previous interviews, by this point, I would be halfway done my function, and I would just be barreling through and talking about it while I was doing it. And so watching this is really, really informative for me personally. And anyways, so it is valuable.
Indentation space. So let's start with like some main method. And then I'm going to be using Java if that's okay.
Totally fine.
So like that's my main method. Actually, maybe I'll just, is it alright if I just write a method that takes in this as input, like you mentioned, this phone number and this words array?
Yeah, in other words, yeah, it can be as simple as possible as far as like the function signature. You don't need to like read from standard splitters.
So you're going to give me this phone number, and then you're also going to give me an array of all the words that are listed. So the first thing I'll do will be static void toNumber, I guess static int toNumber. And then we'll call this phone number letters. And then I'll make int array phone number, goes to int array. So then I'll convert all of these to like a more reasonable format, I guess.
I choked.
So now they're just indexed 0 through 9 instead of the characters 0 through 9. So then toNumber, this will like convert the like some character array into a number array. The word, and then some array numbers. So then, yeah, I guess let's see. Is there an easier way to do this? They don't all have 3 letters, which is kind of annoying. It would be nice if I could do some math there, but it might be easier to just like hard code some array for what works here. I guess are these words are all gonna be lowercase, right?
Yeah, let's assume that everything is lowercase, and for simplicity here, if you can just write like the first letter mapping or whatever you're describing, but you don't have to write all of them because I understand what you're saying.
Sure, yeah. So so it would be something like this. So A, B, and C are all 2, the next 3 are all 3, etc. So that'd be like it shows like for some character what does it map to? The character is starting at A, and then the rest of the method would just look like this. Or minus letter A. So now from this we can turn some word into the phone number digits that it would represent.
Yeah.
Does that all make sense?
Yes, and just to confirm, the phone numbers, or the toNumber gives you a list of integers, you said?
Yeah, so if you pass in foo, let's go to 366, like we talked about earlier. So
But
this array would go to 366 as an array.
As an array, yeah. Okay.
Awesome. Okay, so now I'm going to make an array of integers here, because I think that might be easier to handle. So it'll be word letters length by something. Number of word letters. So this just converts each of these into numbers. So now I'm dealing with things 0 through 9. It's a little bit easier. Okay, so now this is like the aho part, I guess. So well, I guess yeah. Let's just I'll write out the general structure for how this aho thing works, and then we'll worry about the actual algorithm in a minute. But we'll make a try node maybe. I'll just call it node for a try node. And then this is going to have some node array of like kids in the try. So this is going to be some new node array of size 10 because there are 10 different alphabets of size 10.
Okay.
And then it's also going to have some node like a failure link. And this would be calculated by aho. And then it's also going to have a node array like repeat fail or like next with fail. This is also calculated by aho. And this is an array actually, not a single node. So what this does is this is like if we read some letter A, like I mentioned in this example up here, if you have that and then you read a T, it'll say, okay, which node do you go to after reading the T? So in this case, you would go to this node in the bottom left.
Yeah.
So this is what this fail thing does. Okay, so I'll have this Adword signature here. This will have some int array word and then get your next on that. And now we want to build this try here. So we'll have a try goes in the node, and for int array for each array in words. Then we want to add that word try. The word and the index will be 0. I'll talk about how this how we build this into the kids, I guess, because that's pretty simple. So if index is equal to word.length, then we return. Yeah, that's fine. And then I'll also have this return a node, maybe, because that might be helpful.
Okay.
Just for earlier on. And then otherwise, so we know which kid we want to go to. So a kid will be the word of this index. This is what character of the word we're about to add to the try. So now if kids at this kid is equal to null, then kids at this kid will be a new node. And then we want to return, this would just return this node here, but then otherwise we would return kids at kid dot add word, the same word, and then the index plus 1. Go to the next character then. So this will build our try for us basically. So, okay, so now where was I? So we add each of these.
Oh, this is hard to watch. I mean, they're hard to be. These are hard to be in as well, but at least like you have control over the situation. Whereas something like watching this is just because I feel this stress of being. I feel this stress of being lost and being like, oh, there's no way I could do this. But I have to say that every one of the interview questions I've been in has been achievable. I feel like this one doesn't feel achievable based on where I am right now in terms of my progress. But again, I'm just hopping over this guy. So this guy has a bunch of stuff. Maybe he has stuff where he explains the algorithms. Anyways, I needed a mental break from that, so I'm sorry if you were...
We also, it's probably helpful, instead of doing a for each loop here, I probably want to do a regular for loop to make looking up the answers more easy. So, we'll also make a node array like end at, gives me node array word7. So now I can store, for each word, which node in the try that word corresponds to. Since this part is just linear, then this whole thing runs in order size of input, so order total number of characters in the words.
Okay.
So now, like at this point, I would want to build the Yahoo, so we'll worry about that in a minute if we have time. Then after that, I want to go through the phone number. So for an I in phone number, we want to work that. We also want to store which node we're at. So this is like, it starts at the try node, the root of the try. After each step, we will take this next with fail link to see which node we are after reading the next character. So at will be at dot next with fail at which is this index. We also want to mark all of these as visited. I guess all false. So now we'll say add dot visited equals true up here, and then also in this case after we visit a new node, add dot visited equals true. So we know all of the nodes that are visited here. Now I want to do a BFS. So this is the BFS part. First I need to get all of my nodes
It's a
that
breadth
are visited
first.
here. So I'll have a DFS method to add stuff to some queue. So in C++ you could just use a queue. It would look like this, queue of node. I think you said earlier that you don't usually code in Java, but the Java equivalent of this is called an array get.
Okay. DQ, yeah.
Yeah. So it's like an LN queue. I'm only going to use it as a normal queue, but this is like the fastest equivalent for it, so this is what people usually use.
Okay, yeah.
So this is the DFS list. So now for node kid in nodes, if this kid is not equal to null, then dfs.add last this kid. Or I guess we'll just dfs from it. So dfs from kid.dfs, pass in the same queue. And then finally, if I'm visited, so if visited, then dfs.add last add me. Like this. Okay, very cool. So now I need to add all this queue. So this is array deck of the nodes, which I'm calling dfs. And now I want to say the root of the try, which is just try.dfs, pass in this list. This will fill up all of the start nodes from my DFS. So now any node here is one of the nodes that we were at when we were looking through the phone number to see which node in the try we were at.
Okay.
So that's like what's going on so far. Now finally I just need to do this DFS. So while not DFS.remove empty, node next will be DFS.remove first. If next.failLink is not equal to null, and next.failLink.visited, or if it's not visited, then next.failLink.visited equals true, and then add that to our BFS. Okay, so this will now mark all recursive like suffixes. So in this case, if the string were just, if the phone number were just like the equivalent of the word bat, then we would have this. But in addition to marking, you can see B, you can see BA, you can see T, I need to recursively say, okay, you can also see AT, and then you can also see just T as well.
Sure.
So that's what this BFS is doing.
Yep.
Right. Awesome. So now finally I just need to return this answer. So what did I say I just want to return? I'll say we'll return an array list of do you want me to return like the indices or the actual words? I can do either. That's difficulty for me.
Let's return this words, and in no particular order.
Sounds good. I'll just do the same order as input. That's all right.
Sure.
So now for each of these, what did I call this? For each of these endnet nodes, I just need to see, okay, each of these words corresponds to some place in the trie. I just want to see whatever this corresponds to, was that something I was able to visit in my BFS? So for I do 0, I was less than n at one, plus, and we'll have this array list of strings to return, the array list, and return this. So, yeah, okay, so if end at I.visited, that means this occurs as some substring of the target string. So then, what I want to do is add this to the list of things that I can visit. And this will be word letters, and then I just return that at the end. Okay, very cool. So, yeah, so there's one part that I'm still missing here, I guess, and that's this build opera part. So this is the black box that I've left. Would it be maybe a good idea for me to just walk through this whole thing for you first, or should I start working on like reinventing the wheel here?
Yeah, let's start by having you walk me through the entire algorithm, and you can see if you feel like confident in it, and also if you can walk me through the overall time complexity and space complexity, I suppose, by going through it all.
Sure. Yeah. So okay. So here's like I'll kind of separate this with some comments on what's going on here.
Whew. I need another break. This is like so much harder than anything I've seen recently. Josh, you were saying you've been on a bunch of code interviews. How have the questions compared? Like, they haven't been this. I would just be a quivering mess of jello if I came out and had one of these, I think, at least, yeah, much. And I think one of the things that I'm hearing out in the wild, now this is September 17th, 2020. Yeah, the writing the code hasn't really been the problem. I mean, again, I have the small mistakes in that I sort of write the big O squared version, or I get dinged on that kind of stuff, or when they're asking me about what the complexity is, I get that wrong. But it hasn't been, I struggle to write the actual something that solves it. I had one where given phone numbers just like this, you would find out the word combinations. But this is like, and so this one is supposed to be a Google level interview. Maybe for next week we find one that's a little easier. And I think if I'm going to redo this type of thing for a second series, I would definitely put this closer to the end, and I would do simpler ones first, because I think one of the things that I'm struggling with in terms of being able to, and you couldn't solve that. One of the things I'm struggling with in terms of trying to like follow along is I'm trying to watch the way that he solves it, and I'm trying to watch and I'm trying to understand the algorithm at the same time, and one is interfering, I think, with the other. So it would probably make sense to at least start with easier ones. Anyways, I think I'm ready. The question from Clement was, tell me, and the interview themselves are you're so nervous to begin with. But yeah, so I think Clement said, now talk about the time and space complexity of this. So let's listen. We'll go forward on that, and then maybe this AHO happens. I hope it doesn't. I'd like to actually just hear, I'd like to skip ahead to the bit where he says how he did. But let's keep going.
Just like
power
use
through.
a format that I'm comfortable with, which is just all numbers. That way I can index things without having a bunch of empty space. So this is just like make it more comfortable. All this does is use numbers instead of letters everywhere. So the great part about this instead of an ID is we do get spell check.
You do get spell
check.
If
there's one upside to coding in Google Docs, that's it. Yeah.
So then Google Docs isn't delightful otherwise.
I mean, if it had a dark theme, maybe they changed my mind. You just gotta have that. Alright. So anyway, yeah. So for this part, this is just like build the try. And then the AHO cross-tick just runs on top of this try.
Okay.
So I guess let's walk into this Adword method. So I'm going to scroll down to that and then talk
Sure.
about that.
Yep.
So the Adword, this is just like kind of classic college level intro to data structures, build a try. So the idea
Sure.
is we're going to pass in this array. In C++, this is like pass by reference. So in C++, it's equivalent to that. In Java, this doesn't copy the whole thing. It just passes a reference to it. So this is like order one calling this method.
Yep.
But anyway, yeah. So if this means if we're at the end of some word, then we just return this node. So this will return whatever try node corresponds to this word, assuming we've already processed index number of letters in it.
Okay.
Then we want to look at which kid we should go to from this node. So that'll be this part right here. And then if that kid is null, that means we haven't seen, so like let's say we're at like AT or whatever, we haven't seen another T yet. So we need to make a new try node for that so we don't have a null pointer exception. That's just what this does.
Yep.
And then we just recursively ask our kid, well, for the rest of the word, what would we be at? So since the rest of the method works, that part will work as well because we have our base case here.
Sure.
So yeah, so that's how we build a try. Then we would run AHO, which I'm pretty sure we can do just with a BFS going down the try. But yeah, so anyway, but then
And just
moving
before,
on from that.
sorry, David, but just to cut you off, can you add also the like time complexity of each of these parts?
Sure, yeah, for sure. So this part here, this is like order sum of sizes, sum of word sizes.
Yeah. So like it's the total number of characters in the entire words array is what you're saying.
Yeah, exactly.
Okay.
And it's both that size and space complexity worst case.
Yes.
And then yeah, what else is this? So this AHO is the same thing. So it's order sum of word lengths as well.
So
for
AHO
both
runs in
size.
it runs in linear time.
It's just a BFS. Yeah.
Yep,
Just
okay.
a clever BFS. And then this part, what am I doing here? Okay, yeah, this is just like we mark, like we literally just traverse through this thing. So it might be more helpful to put this here. This is like we just walk through the phone number part. So this part here will just be order like the phone number for
Right.
that much time, and then order one space. But I guess we're already storing the phone number here, so we're not going to be order like the phone number space anyway, like in the grand scheme of things. But I guess
Yeah.
that's not too important.
Yeah.
So what this does is just AHO will give us if we fail for each letter, where do we go to, and that's calculated in this. Oh, I've done something. That's calculated in this part here. If I were to write that method. So we can just walk through the try for each next step, saying what character do we go to, and then we mark all of those as visited, saying like you can get here from some.
The thing that he's doing there with the comment that has the big O on each thing, that's something that I've never seen before, and it seems really, really useful. I would call that out as like, wow, do that, that's really great, because if you're writing it down as a comment over top of each operation that happens, as long as you get it right, you can then go through the entire algorithm looking for the pieces that are in there and put them all together. That's a really good strategy that I haven't seen before, and you know, it makes sense that he would be the Facebook software engineer and I would be the lowly scrub.
Prefix of the characters, and then by doing this BFS right after, we want to say for the rest of the characters, there's some suffix of each of these trinodes that are visitable. Which ones of those can you pick?
Right.
So then this BFS here is just a normal BFS. So since the total number of nodes is the total length of the sum, like the sum of the word lengths, then this BFS will run in that time because the number of edges is just the same as the number of nodes, because the number of edges is a tree basically.
Yeah.
So this part is also order sum of word lengths. Okay, very cool. And then, yeah, finally at the end, we just iterate through. So we stored for each word that we're considering, which trinode does this correspond to? So I just iterate for each of those and say, okay, if this node was something that's a suffix of one of the trinodes we were at while iterating through the phone number, that means you can make it by some suffix. So I add it here.
Right.
And yeah, that's the idea behind it. This DFS just like looks through all nodes, so that's not really worth covering, I don't think.
Yep. And
So I'm pretty confident in the general idea. It might not compile. I might be missing a semicolon or something. But that would be pretty easy to fix if I had like if I were able to compile.
Yep, exactly. Yeah, and I don't think we need to check that right now. I think we could check that if we wanted to, but I don't think it's super important here. And so overall, the total complexity of this algorithm is.
Oh sure, yeah, I should definitely cover that. So overall, it's order length of phone number plus sum of word lengths. That's size and space. Now, if you don't count the space of the phone number letters, so if you don't count the space of this array, then it would just be this much or this much time, and the memory would just be. So it'd be this much time. The space would just be the sum of word lengths for the space. Oh, I guess that's not true. No, because I make an array somewhere, so it's both this time and space.
Okay.
Just kidding. Like the reason it uses that much space is because I make this end at array. Wait a minute. Hang on. Give me like 10 seconds here, and then I can get you an answer for sure.
Take your time.
Yeah, so it's not. It's not. It's actually the space complexity is what are some of the lengths. This is just the time.
And you're still there, right?
I am, yeah.
Yeah. And so the reason it's some of the word lengths, especially with regards to the tree, is because in the tree, when the try, effectively, like, you have each word at most once, and even some characters are repeated. Like, some characters will be kind of
Exactly.
duplicated. Okay.
Yeah, so it's probably going to be a little bit less, but like worst case, it
Right.
might be you might have every character or almost every character.
Right. Okay. And then of course we have also like the digit phone numbers and all that, but those are all either the same or less than that.
Yeah.
Okay.
I suppose this might make it linear on the phone number length as well.
Here we go.
That's kind of like small details, I guess, that are too relevant.
Oh yes, if you're creating also the phone number, if you're storing that as an additional thing. But yes, okay. Okay, great.
Awesome. Well, yeah, thank you for the interview. I appreciate it. It was a fun problem for sure.
At this point, I think we're done. Thanks so much, David. But this is like right on time. We've got 1 minute left, so maybe now we can do like a quick debrief. So maybe like why don't you start by telling me and the audience like what did you think about the problem and how do you think you did and all that?
This Dyson high-speed hyperdymium motor and DLS technology.
I feel like, to Glenn's point,
Well, it was a-
that ad came at a perfect time. I like this strategy on the. Do they post this code somewhere? I don't think so. But this Algo Expert is a paid service. There are some. We can actually hop over there. I actually want to hear more about what he has to say here, but how much is it? Let's look at how much it is. So you get it for a year for $130, systems only or algos only. I guess what? 4 timed coding assessments. I think. Okay, 155 questions, 2-part video explanations, in-depth time and space complexity analysis. But bonus interview content, unlimited mock coding interviews. So that one's really interesting. So for $100, you are able to. That seems like, so they're going to pay somebody 45 minutes for this? There's something wrong. There's something that doesn't make sense. But I mean, it doesn't seem like a terrible service. Maybe I'll try that one day, but not now. But explore questions. It's not letting me. Okay, so let's look at a. Yes, tries. Here we go. Validate subsequence. Okay, so this is. I'll snap video to see. Snap video. Oh, I see. Yeah. So you're just going to try and get it out and see what's going on. Your solution. Solution 1, Solution 2, Solution 3. The tests. Okay, so this is just like any other question, but this is built, or any other leak code or hacker rank, but this is, Anyways, so let's see what the rest of this, how do they wrap this up?
It was a really good problem. I really enjoyed the problem. It was super cool. I guess it would have been helpful if I had coded this recently, because it would be easier to not have to, black box it when I'm explaining how it works. It would be easier to just not say this is a well-known thing and instead just explain it for the first time. But yeah, so I guess this is the main thing that I wish that I had done better. This having this black box here.
Right.
But beside that, I think I feel like I was pretty comfortable for most of it, and I think it went pretty well. I guess I don't think it's possible to do better than this runtime if you're doing everything in a single processor. I think this is the best you can possibly do. So
Yeah.
I don't think there's like a better solution out there that I'm missing. Maybe, I don't know, I'd love to hear, is there just a simple way of doing this that I just didn't see?
No, so I guess like if you want, I'll give you like my thoughts. So I think you did super well from an algorithmic point of view. I think you did really fantastic, and I really want to emphasize this to the viewers. Like the solution that David covered is not the solution that I personally would expect in an interview. I went with it like at the very beginning. You even asked me, you were like, do we care about this solution or do we care about the like m squared solution or whatever at the top? Like if you scroll up, you had written a different solution path, David. And in an interview, I would not expect someone to go through this with the like AHO algorithm and all that. And I was expecting more of a you can build kind of a what's the word, like a simpler version of a suffix tree kind of structure that would run in m squared time with respect to the length of the phone number, for example, if you dump every suffix in the phone number in that tree, and that would be like acceptable in a coding interview. But David like knew about something even fancier and even better, went with it. I think it was great. I think it was better to not have you write out the AHO algorithm because like at that point, like I trust that you are familiar with that and that you kind of know how it works. And I think I've gotten enough signal from your algorithm skills. I don't need you to jump into that and to try to reinvent the wheel, like you said. And you would probably just use that from like a library or something if you really needed it on the job. And then we're communicating really well. I didn't lose track of you at any point. The one like super tiny nit that I will give you, David, if you want, is just like here with the BFS. I got a tiny bit confused because you named
Yeah, just here's my AHO code. But yeah, anyway. Sorry, what were you saying about the BFS?
Yeah, I was just saying that you named the you named the Q BFS, which I found a tiny bit confusing because like you use DFS as a verb, but here BFS effectively is like a noun of the
Is
Q.
the name of my queue? Yeah. Maybe I could have done a better job there for sure.
But I mean that's like and I ended up following you. But you see like here like tree.dfs passing in BFS like reads a little bit like
a little bit confusing, yeah.
Yeah, but apart from that, like great job. Like I said, all the rest of the code was great, and your communication is like fantastic. You walked me through everything, totally understood. Like, and again, like I gotta commend you for being able to explain something that is a complex algorithm with an even more complex solution than maybe the expected one to someone who might not be familiar with the way the algorithm runs and everything on Google Doc. So great job.
Well, thank you. I appreciate it, and it was a fun interview for sure. I enjoyed the experience.
Awesome. Well, maybe if anybody's curious, they can go check out. They can go look up AHO. Maybe I'll put a link in the description below to that. Thanks again so much to David for being down to do this interview. Go check out his channel. I'll put the link to it in the description and in the comments below. He's got a great channel, great guy, great competitive programmer, and thanks a lot for doing this, David.
Yeah, thanks for having me.
If you made it this far, don't forget to smash the like button, subscribe to the channel if you haven't already, and I'll see you in the next video.
Yeah, you're welcome.
This Dyson high-speed.
Okay. Oh. So that's the story of what it's like to go through a coding interview. maybe we'll look for one that's a little easier. And where is the rest of this week's plan? I'm sorry she didn't. So I actually while we were talking, I looked up. There is a Ben Awad who is another. He's another YouTuber, does this stuff. Did an interview with Clement, and this one is for an easy coding question. But before I wouldn't want to start another one right away. I kind of want to see how do we feel. Is there anything that I haven't said? What are your thoughts in terms of what we could take away from watching that experience? So, like, it was. It's the algorithm that got me. I feel like it's a lot easier when you can kind of follow the algorithm yourself. And actually, there was one that I wanted to get because in my search, there was another one for a Ben Awad. There's one where he did a React beginning React coding interview.
Welcome, Clement, to the Awad Incorporated interview. This is cool.
Here we go. So this one is one that I also want to capture. Ben's content is actually super funny. I have not yet vetted this one, so I don't know if that's a serious React coding interview. It does say beginner React. Yeah. And one thing that's important to note about Clement, he is a former Google programmer and interview. So he has done this professionally, and that's really important to note. Yeah, don't be in a hurry to start the coding. Explain the solutions to the interview and be able to explain your approach thoroughly while you're coding it. Yes, and the space and the time complexity. That was actually the first time I had seen that, and I think that one. I think if I was in a hacker rank or something like that, let me pull up LeetCode, LeetCode.com, because. And so this is my daily check-in. So let's go to the things. So if I went over to my problems, I'll go to one that I have previously solved. How do I do that? So I go here. Oh, yeah, here. Got one with it. Can I sort by check mark? Yeah. So this was pretty interesting. So I could go into the strong password checker. Open up. And so in the world where I'm doing a coding interview, I could actually go in and say, so I've got the string password, so and if I go from here to here, what am I looking at? So this scales with the O of password dot length, or I could actually translate it into English, the length, the password, and that seemed like a really good technique because you could do that in real time as you were going through the interview itself. And you could probably look repeats.add number. So there's no loop inside of this loop. So realistically, so there's that. And then you look at, anyways, I'm not going to go through this whole one, but it was, which is O of, and yeah, I guess O of, yes, that would be an O of n because it scales linearly with the, and that was interesting too from what he did, because he didn't actually boil it down that far. He put these, yeah, but it would be the length of the password is the O of n, handle short password. I'm not going to go through this. This was a really hard one. And I'm not going to do that. But that was a really interesting technique that I saw. And it's sort of something that we can get from this. So what do you think? I feel like we have 2 or 3 of us who are really interested in React anyways, including me now, because I am soon to be a React developer. Do we like, and I'm hoping this is an easy one. So, and he says beginner, although I haven't watched it. So do we prefer the React one or do we prefer the easy Google one? Let me find out how long this one is.
Not knowing how to invert.
What's up, everybody? How's it going?
There we go. So there's 27 minutes and there's 36 minutes. They're about the same. React, any other votes? Let's view it. Okay, let's go. Yeah, I think so. I think this, I know that at least 2 others who are with us right now are interested in more React. So let's watch this and see what we can learn. Especially, I happen to know that Well, it's too bad our friend isn't around who just did a React interview. We could get another point of view in terms of how accurate this was. So, and I hope this. I don't even know if this one is comedy. I hope this one is real, but let's play. Let's find out.
Going to be a React interview to test out your skills. But before we begin on the coding portion, I would just like to quickly ask you why you're interested in working at Bin Incorporated. That way we just get a little vibe to see what kind of person you are.
So the truth is that I was bullied into doing this interview because this person by the name of Benjamin Awad wanted to put a washed-up front-end developer to the test in front of millions of users on YouTube. But so that's why.
This sound is really bad for me as well.
We want employees here to be strong and independent, but let's hopefully your React skills make up for this. But we're about to find out. So what I'd like you to do first for me here is I want to start off real easy, get you warmed up here. Could you make just a counter for me? I want to see like the number 0 on the right, and I want a button, and I can press that button, and it increments to 2, and then increments to 3, and so on.
Sure. Okay. And the button for as far like CSS goes, is it fine if I'm just like putting the stuff on the page without?
Yep, default HTML elements, all good. No styling required whatsoever. The uglier the better.
Okay, the uglier the better. This is my jam. This interview just got really fun. Alright, so since they're importing React like this here, I'm just gonna grab use state from React like this. We're gonna keep track of a counter in a state variable. So we'll say const counter set counter equals use state. And you said you want the counter to be initialized to what? 0?
0. Okay. Surprise me.
Okay. And then here we are gonna have, I guess we want this to be really ugly, right? So let's put this in a p tag. P tag.
Fantastic.
And we'll have our counter. Perfect. You see that 0?
I do. Loving it already.
And then we'll put a button. There's no autocomplete here. A button, which is going to say, I guess, an increase counter. And we'll have an on-click function. And the on-click will be like, I guess I'll only do this, set counter to counter plus equal or plus 1. Let's see. So when you press the counter, you set the counter to whatever the current counter is, plus 1. So if you increase it, it goes up. Are you seeing, by the way, if I'm pressing the button, are you seeing it go up right now? We're at 17.
I think we have independent review, so I can't, but I believe you because I'm pressing it and it's working great. Fantastic.
Okay.
You have passed test number 1.
No, wait,
So now we're gonna.
Oh, it's not.
So you're getting much closer, but I gotta make sure that have some real life skills here. And so what I want to test out next is hitting an API. What I have here is a random user.
Now, how was that one compared to the one you did, Josh? That one seems pretty easy. I mean, quite clearly you would have to know React to get anywhere in that. Pretty easy. Yeah, okay. Here, let's look.
API. I don't even know what data it gives back to us because I haven't used this recently. But what I'd like you to do, just so we can see what data it gives us, is could you fetch this API and then maybe just display as a string and React so we can just see what the API gives us here.
So let me see. Yeah, is this like a legitimate website?
No, yeah, it's legit. If you do a GET request, it'll give you JSON back. So I'll tell you that much for sure.
Okay.
But what the shape of that JSON is, I didn't bother to look. So I forgot what it is.
I see. I just went on it. It looks like it's a JSON object. So I think for this, I'm going to use a library called Axios. Can we import Axios in this? We can.
Yes. So I believe if you just do import there, you can it'll just prompt us to import it. And I forgot to mention this, but like feel free to Google things. Stack Overflow. If you need to do anything.
Yeah. Fine. So let's see. Axios.
Yeah, and if it doesn't auto add it, I believe it should auto add it. Or not auto add it, but prompt us on the right in a second.
Yeah. So Axios. Let's see how we use it. npm install sure. So you require Axios, and then it says you use axios.get. So like I'm going to copy paste this something that's seen on the npm page. So this is what they do on npm as an example.
Mine involved API calls, sorting data, and some date computations, as well as creating sortable data tables on the front end. Part 2 involved more API calls and creating an email template, versioning systems. So you did 2 different tests. And this one seems a little closer to making API calls. And so I think the value that we might get from this is just watching how Clement goes through and, like, I'd be interested to know, did you talk through the stuff you were doing in this style as he's doing? Because this is probably, the thing that the reviewers are looking for. Anyway, I'll stop talking.
So
we'll let it go.
If we could just do that, we would have. I'll put a function at the bottom of my component, but this would probably be like in a separate file. It would be like an API file, but it's fine if I put it here.
Ooh, bonus points for best practices. Okay, I like it.
But you want me to actually create another file? Or
No, stick it here. Stick it here. That's fine.
Okay, cool. So we'll create a function, so we'll call it
If we had gotten our
fetch
hands on that,
random
'cause kind of quite famously, we
and,
could get our
in
hand.
a hard code path, we'll
Apologies.
return
I'm
Axios
just gonna try and
as
ban
properties.
that dude who
Put it at the bottom
spammed
here.
me.
Should not be commented out. Let's uncomment this. Okay, so return axios.get. And this is, we're gonna grab this, and we can just pass in this website, right? We'll make a request like this. Why are they not using ES6 functions here?
That's a great question.
For here, I guess for now we'll just have like error. Do they have the types? They don't have the function response. Any? Is it fine if I'm just typing these as any for now in TypeScript?
It's leave it totally up to you, whatever you prefer.
Alright, it looks like they're allowing me to do this. Whoops, whoa, I just click. We'll see
Thank you.
that.
My eyes were bleeding having to look at the word function there. Glad to see arrows are back.
Okay, so let's see. Right now we're just console logging. So this, by the way, would return. I guess the type is inferred, but it returns a promise.any. And here we probably want to return was. We guys remove this site because it's inferred. Okay, so let's have a button that calls this API. Let's see if this actually. Oh, did I just type? I can't. I don't have a default VS Code key bindings in here. Okay, so let me do another button. This will be fetch random data. Do I have a place where I can see logs by the way in here?
Yes, if you it should be at the very bottom of the website on the right. Should have console on the left side.
Okay. So let me see if I were to console.log in the chapter, console.log foo, and then I press. Okay, cool. But you can't see my logs, right?
No.
Okay, so on click for fetch random data, we're going to call fetch random data. Let's hope that this Axios thing actually works. Fetch random data. Data. Why is this squiggly? Fetch random data was used. I put this at the top. This is why you would want to have this in another file. Actually, that was weird. Okay, so fetch random data. Let's click fetch random data and see if it actually works. It did work. So I returned data results, and it's in 0, gender, female, name, object. So I'm getting basically a bunch of information from some random user, it seems like. And it's not the same info that I was getting on the other website when I went on this, so I'm assuming it's generating it every time you fetch.
Yeah, the contents, the shape should be the same, but the contents are random.
Yeah, and what do you want me to do with this?
Could you just start by just dumping it to the screen as a string? I want to see the JSON just spewed all over the browser, right?
Just completely speed. Alright, so we'll have another state variable, which is going to be, I suppose, random user data JSON. And by the way, I'm a big fan of Java variable names, aka very descriptive variable names, so I hope that.
I mean, we're in TypeScript, so it's understandable, I suppose.
Exactly. Okay, so I'll declare this state variable as an empty string, and here I suppose that then this will return. I guess we can destructure this res to be data, and we'll return JSON.stringify data, and I'll console.log the data still. And then here, fetch random data. So fetch random data. This is a promise. Ooh, should I use async await?
That's a great question. Should we?
And actually, do you mind if instead of actually, should we make it in the button or should we fetch this on page load?
I'll let you choose either. We're gonna do one of those in a second, but yeah, for now, pick whichever one you want to try out with.
Okay, let's do on page load. So I'll add a use effect here, and we will do the use effect that only gets called on the first time. So this is very intuitive. Pass an empty array here. This will mimic component did now, right? And then
Shots fired, Dan.
Shots fired, man. We will call fetch random data in here, and I guess we'll make this async await. So const random data, let's just call this random data equals await fetch random data. Then we will set this here. I'll have to make a function async second, and then here we will. When we don't need this button anymore, so we'll remove this button, and we'll just have another key tag. So another key tag that has in it the random user data JSON. I suppose this should be more of a string. And so this is going to be is async. Does async go here? Let's see what's going on here. Argument of type unexpected token. Really token. Unexpected token. Expected. Oh, and is my weight? Let me see. You know what? Then my async await is feeling a little bit washed up right now. So instead of doing that, I'm going to do fetch random data dot then, and then I'm going to set this in here. And
It works.
We're not going to catch any errors because we don't do that here.
Oh, our code doesn't have errors, right?
Yeah, exactly. But you're going to have to forgive my typings. I feel like maybe we're just better off going scuffed TypeScript here.
Yep, and I love scuffed TypeScript.
String void. So I guess here we can put like or this, or here like if you want to be really fancy, you can put like an error message that says like no user data.
Don't get too fancy for us. We're in React here.
Okay, so does this look good?
Yep, this looks great. And I'm just gonna just make this a pre tag. That way we can see the data all pretty.
Okay.
Maybe
sure.
just say like null2 here. Null2. And does that? Yep. I don't know if it made it that much prettier actually.
Oh, fancy. It's like a little bit ugly JSON, but it's.
I think it's because it's trying to center it or something. I think the styles. I think it's the styles there. I just kill that. Yeah, that's what it was. All right, now our JSON's a little bit prettier. All right, I just wanted to do that also so I could see what the JSON shape actually was.
Yeah, but I will say I'm actually having like kind of fun doing just like normal React, not like algorithms, not a real product where you're stressing about building like, the best user experience. You're just like coding. This is fun.
You're just code React. React's fun, you know. This is great. And you're doing great so far. We actually have passed 100% so far. My next thing that I'd like you to do with this data is, to actually display the results as like some UI components. So nothing fancy here. I just want to see like the name of the user, and then also let's do like I believe a picture's in here. Yeah, if you could just display like the name of the user and the picture.
Okay, so let me see. For the results, actually it was kind of nice to put them like this. That way we don't need to look at the logs. We have the results, and do we have multiple users? No, we only have one. So.
Right now we have one, but assume for this that we may possibly have more than one user in this like results array.
Okay. And so you want me to effectively display every user name and every user image on this page?
Yep.
Okay. So let me think about this. I think we're going to want to store our results in a state variable for simplicity. So I'll have const I'll put just like user infos set user infos equals use state. This will be an empty array. I guess I'll put the type as like any for now, but this would be like whatever the results type is. And so then here, this random data, we will do set user infos to be the random data dot results, right? Let's see why this is squiggly. Probably doesn't always work JSON of string find. So you know what I'll do instead of stringifying this data here, I'll put data, and then here we'll put random data. It's JSON of stringify random data, and then remove the semicolon.
Yeah, you don't need to display the JSON anymore if you don't want to.
I'm keeping it now just for a second, but then I'll remove it after. Okay, so we've got our results, and so, or user infos rather. For now, is it fine if I go like modularize this, or do you want me to make like another component to modularize like user results?
Now don't worry about like a component thing and all that jazz. Just do it the you find the easiest way.
Okay, so then under this button here, we'll do something like user infos dot map, right? Because we've got an array dot map. We'll have a user info and an IDX, and this will return. I guess we can put yet another p tag, and here this will be something like get full user name, passing in user info. I'll have this get full username function here that takes in the user info, and it returns. So we have names. It return user info. Actually, let's remove this. We'll do const. I hate that it re-renders automatically as I type because I can't see. So name.
Then you can't see the JSON.
Yeah. Name first last. Okay, so we'll do const name first last equals user info. Return first and last name. And here, by the way, I'm assuming that I've created an agency to display this as I want. But if you want me to display this in a different way without like the first name first, whatever.
No, that's chill.
Okay. So get full user info. Why is this implicitly has any? That's fine. And then I guess we will put an image, and I'll wrap this in these empty tags. Image. Let me remove the image for a second, actually. So is this actually showing up right now? Get full. Doesn't look like it's showing up. Why is it not showing up? Give me 1 second. Let me add just a key here for semantic React. Oh, because I have an arrow function and I don't have a return. Does this look good? We need another parentheses. Does this look good? Yeah, there. Writer Coty. That is an interesting name. Writer Coty. Writer Coty. Coty is a French word. It means side. Okay, so we've got full usernames. Yes, I don't care that this is any. In theory, since this is an interview, I should behave as well. Interface user info. This would have we said what does it have? It has at least a name property, and here we can do interface user name, and this is going to have a first, the last, and a title. Whoops. Okay, this is going to be the user name, and here I'll just put this here. Even though this should be for somewhere higher up, we should probably have the random data define, what the random data looks like. Okay, so why is this complaining? Cannot read property results of undefined. Why is that undefined? Did I mess up something?
Where does it tell you there's an error?
Here on line 44.
So for me, it actually has a squiggly on line 32.
Yes, I have also the squiggly on.
Okay, you have both.
Oh, this is username, user info. Okay. So this squiggly line on line 44 was a bug on their part, I think. But the bug was that user info is user info, not username. Okay, so we've got this. You want me to put the image tag now?
Yes.
Okay, so the image, where do you find it? It's under picture. Okay, so then here we'll put picture and user info interface at the top here. Oh my god, I hate how it recompiles. Okay, picture, large, medium, thumbnail. Is it fine if I go with thumbnail?
Yeah, whatever.
Okay. So picture, we'll put, interface, user picture. We'll just put thumbnail for now. String, user picture. And so here, it'll be image. Forgive me if I don't know how to render an image in React. This is how you do it. We'll do user info dot picture dot thumbnail. Okay? Yes, it's showing up. Is see
Excellent.
a picture of someone.
Alright, I'm thinking we do one last thing. So we have the results, and what I'd like to do is add a button here to load more results. Kind of like paginate through the list of users. Now I actually don't even know what the thing for this is, so I'm going to check the API, and then I'll tell you what the actual URL parameter passing is. So the API, if you put this URL param, page 1, page 2, page 3, it'll give you the next page for the results. So if you could add a new button that's like load more, and we can press that button, and what it'll do is it will grab another user and it'll display them.
Okay, and do we want to display, do we want to just append to the users that we're displaying, or do we want to just display the next one? Okay, append.
Yep.
Okay, so then fetch random data will likely take in a page. So it'll take in a page number, which is going to be the number, and we could probably default this to 0. Does it start at page 0 or page 1?
I think it starts at page 1.
Classic non-zero index.
I'm just taking a guess though, but yeah.
Okay, so what I'm doing here, and by the way, I'm kind of working off the cuff here, so maybe there would be a prettier way of doing this, but I'm just going to add a pagination.
Yeah, but in all fairness, he would probably get the job. He would probably get the job.
Token number here in this method, we'll default it to 1. So right now, our initial call is still calling the first page, right? But if we pass in another, then it would pass in. We can still call this with another number. So we're going to have our get method here that adds in the query param. So this is going to be page equals, API/page equals page number, right? Okay, so this seems to still be working with page number 1. And so you want us to append stuff on this new button that is going to call the next page. So that means that we need to know what the next page token is. I'm assuming this returns the next page token. Does it? Yeah, it returns info page 1. So we can presume that the next page is page 2, and we can presume that there are like an infinite amount of pages.
Yes.
Okay. So, boom, we have user info. User info is here. I guess I'll have like another state variable. Another state variable that's gonna be like next page. So const use next page token. I'm so used to Google APIs where we always do next page token. We do next page number, set next page number equals use state. The next page number is going to be 1 at the beginning, and we can actually, if we want to be more explicit here, we can always use fetch random data with the next page number, so we don't need to make this default to 1. And then set next page number. So here we'll set next page number to random data dot info dot page plus 1, right?
Yep, that's looking good so far.
But it is erroring out random data update. Okay, and here again, I should have defined the interface of random data somewhere, but let's just go with this for now. Okay, so set next page number. So here we will have a button under increase counter maybe. By the way, let me comment that as JSON. So button under increase counter. I don't have an idea for debugging. It's totally fine because I'm an adaptive software engineer. I'm going to adapt to a new ID on the spot. Okay, so what you're going to do, this button is going to be fetch next user. Let's call it that, and it'll fetch. Let's see here. We're going to want to clean this up a little bit. So at the very beginning, we are going to have a function here. I'll write it here, which is const fetch next users. Okay, and what it'll do is it'll do what we call here in this use effect, and we'll call it a use effect. So here I'll have like fetch next user, but instead of setting the results it'll say const new results equals or new user infos equals, and we'll take in the existing user infos, right? And then we'll take in the random data dot results, and this will be then set here. Okay, so that way we can just reuse this function all the time. Let me remove this thing for now. We'll call this out. So fetch next user. So here at the very beginning, we would be fetching the next user one, or sorry, we would fetch next page number here like this, right? So this would be we don't even need that. Okay, we do this. Although we would maybe make it more functional. I kind of prefer more functional, but I don't think this matters right now. Okay, fetch next user. And then, whoa, why am I getting a bunch of users right now? I must have.
Try refreshing the page if you want to start from, because it's hot reloading on you.
Oh, it was already added. Okay, yeah, I'm seeing only one now. Vicente Morales. Okay, so then on a button, fetch next user, we're gonna do on click. We can legit just call fetch next user, and I think it's gonna work. Oh, it's beautiful. It's working.
It is.
Although I did that. Oh, I think I hit the last page. Ooh, look, we can be even better. We can say if random data equals undefined, and we just return. And that way now I can spam this button and I never break the page.
So this is fantastic. I have like a little bonus for you, because on line 59, I don't know if you noticed, there's a little bit of a linting question for you there. How would you go about satisfying the linter there?
So it's funny, I just saw it, and I was wondering, I hadn't hovered over it, I was wondering why is it linting, because I've never had a lint on an empty array use effect before. React hook use effect is a missing dependency, fetch next user. Either include it or remove the dependency array. Fetch next user. Okay, so if you're asking me how I could like remove the lint, I think I think
That's
TS ignore. I didn't do this. Oh wait, why is TS ignore this in there? Oh, it's ES lint. So I could do the equivalent for ES lint if there's an equivalent, but I'm not sure what it's telling me. Is it that yeah, what is it? I'm not sure what it's telling me.
So
do you want me to look this up? Or?
No, I can give you a hint here. So what it's saying is you're using fetch next user here, right? And that's a variable.
Yep.
And this variable could change. And so that means the reference could change. Some things could get messed up. You could have problems with closures and functions. And so what it's asking you to do is stick everything that you're using here. And so what will happen is every time that fetch next user is changed, it's going to rerun the effect, right?
Yeah, but why would I want that though?
Well, okay. So why you want that is I'd have to think like where the case this comes up, but basically. Fetch next user is captured basically on mount, and it's never being updated. So in this case, it doesn't really matter because you only want to run on mount, right?
Yeah.
But basically, fetch next user could change, and that's what it's.
Yeah, because look, I could. That's weird. Because I could do this. Like if you want to do something fancy, like if you refresh the side thing, right? We could do like use effect, and when the counter changes, we grab this, boom, and when our counter changes, I still have to refresh. When our counter changes, then if we increase the counter, you see how it fetches. It basically we don't need the fetch next user button. And I'm still getting here the same link.
Because it's still gonna want it. Yeah, it's still gonna want this because it's inside of here. So it's React wants you to put everything that you're using inside there, or as a dependency.
But now what's the same on the actual fetch next user function? It's like linting a ton of stuff.
So
if you add it.
This is one way you can do it. It's I guess you'd say slightly jank, but you could create like a ref to the function. So I could create this.
Like use ref.
Yep.
Yeah.
And we have to import that. And then here you could say .current is equal to that, and then you could call that here. But to be honest with you, maybe someone in the comments can let us know. You could probably just ignore the linter on this one, because I think it's gonna work fine without that one. But usually, Dan always tells me never ignore the linter for that. So this is how I would get around it if I wanted to like listen to the linter. Is I just turn it into a ref, and then I can do.
Like I've never seen this linter error before. Like I've never.
Algo Expert needs this in their code base. They need their ESLint turned on. This is standard for hooks. So you gotta do like if 5, right? Return true. Should stop you from doing that, right? Because this hook comes after it. Have you gotten this before?
Well, I think this we get, but this isn't. Is this ESLint as well here, or is this even just TypeScript telling you that you're not calling everything?
I think it's React hooks rules of hook lint for you.
Oh, I see.
Yeah, that's good to add if it's not in your guys' code base, because it'll catch some stuff. But I mean, as you solve some stuff, for the most part, you should be listening to that lint rule. Usually that lint rule.
I'll have to talk to our front end dev who watches all your videos anyway, so we'll probably be watching this. And he probably, for all I know, I gave you I told you something incorrect. You had it in our code base, something was like a cat missing stuff.
I guess we'll find out. You're not as washed out as I thought you were gonna be. You went through it like very smoothly. I thought we were gonna have more bugs. I would have made it harder. I would have made it harder than this if I knew you were gonna do this so smoothly. You impressed me.
I passed.
You
I
passed
the, like,
for sure.
The like basic Ben-A-Blog test, but maybe not the like elite Ben-A-Blog
Well,
test.
here's the thing though. Like every website, you're gonna display a list that you fetch from an API and have pagination. So like you showed me you've done that. That's literally like most web dev anyway. So.
Yeah, but on some websites you have to actually allow users to like type their code and run their code and change their programming languages.
Next time you're gonna implement authentication for us, okay?
Oh no, please don't make me work with like auth APIs. But okay, Ben, I can say one final word to your viewers. First of all, I hope that we entertain you. And if you enjoyed this video, then let us know in the comments below. Maybe we should do like a second version of this. We can do a second version of the video that we did on my channel. That might be fun.
Yes, so if you have not already, go check out Clemens' channel. There's a second half of this video where he interviews me, and let's just say I did surprisingly bad or surprisingly good on the algo test. I'll let you guys see. You guys already know how I did though.
There we go. That one was fun. I mean, it was a bit more comedy than I expected. I don't think that you would get that same level of attempted humor and camaraderie coming out of because interviewers are actually trained to not show that level of emotion and stuff. But I mean, that was a nice refresher coming out of coming out of the first one, which was painful and hard and it hurt. That was like watching a couple of like easy listening shows. Like you just finished Game of Thrones and you're like, oh, I think it's time for a round of New Girl or something. So that was good. So this plan did not... Oh, let's talk about Pramp. This was really interesting to me because Pramp, if you are looking for code interview, so find a mentor. I only just learned about this while I was looking for code interviews to show during the study session today, and the way this one works is Pramp is a free online peer-to-peer platform for practicing tech interviews. And so, and how does it work? You get automatically matched with engineers. You do live one-on-one video sessions through their website. It's sort of like, you remember Chat Roulette all those years ago? So it's like Chat Roulette, but you do programming questions. And you do one round where you are the interview. So you do, goes both ways. You do one round as the interviewer, and one round as the interviewee. And this seems like a really great way of getting that practice in the interviews, because you see what and so that's what they're saying. You see what other people do wrong, and you're like, oh, I can not do things wrong as well. And then you do them yourselves, and they review you and your performance. Again, like, is it really free? Yes, it's really free. Why is it called Pramp? Practice makes I like that. That's cute. Pro champ or winner. Why do I need to sign up? No, don't care. No. Anyways, I think this is really cool. And it's a really great resource to try out. Practice now, free. Okay, so they've got like a little blog. Anyways, so this is really fun. I've got to explore it more. I take responsibility for Amy not showing up. I did not do. I missed a step in the sending of the scheduling, and so I screwed up there. I had we had numerous back and forth in terms of oh wait, file could not be edited. Create week 4. No, this is React coding interview beginner. Okay, commit changes. I've made commits since. Oh, maybe I've already saved it. Okay, well that's fine. Let's go back to the course. This was special guest. Oh, anyways, no, she was really excited by it, and I must have screwed up in sending that calendar invite, and that kind of makes it entirely on me. In other exciting news, I wish I could show you the camera that I can. I just bought like a super duper camera. Let me open up a Zoom and I'm going to show you. It's so cool. I'll go settings, video. So, okay. So you can see, I'll move this up here. Check this out. Take this. Look at this camera. Oh my God, that's an amazing camera. Oh my God. Like, look at this lens. Whoa, I'm like a superhero. I am like a camera superhero. That's super exciting. You know? Anyways, I think 2 of them is enough for 1 week. There's a lot of incoming information, and we're 20 minutes from the end. If we want to talk about, so this lens is, I have the box right here. Hold on, I kicked it underneath the couch earlier, or did I? Where did it go? So it is a Sigma lens. It has an f-stop of 1.4, and it's a 22 millimeter. So the camera itself is a Canon M50, making it so it's a mirrorless digital camera. But this Sigma, so the f-stop 1.4 means that you open the aperture all of the way up, and you get, so this blur effect that's going on in the background, that's real. That's a real blur effect. It's not like some filter. Yeah, it's just so good. And I got it because I've been doing more of the interviews and things, and I'm going to start doing, as I was saying, I'm going to start recording the summary of like clean architecture. And so if I'm going to be doing more of the high-end YouTube stuff, it's nice to have a high-end camera. But yeah, it's a really great camera, and the photos, the quality of the photos it takes, mwah, chef's kiss. Anyways, this week, let's look at next week. I even went through on the weekend and I started laying down plans for the rest of these things. So in theory, if you wanted, you could look ahead. Algos in detail. Where's week 6 or week 7? We have a bunch of stuff for system design interviews. Anyway, so I've started putting more stuff in here ahead of time. I got a really great, what is that? System design interview prep. Oh, this was really exciting. Edit, open in Google Docs. So, this was a post I found somewhere. And Pooja Biswas. where I believe that's a she. Yeah, so she went through and put together this incredible list. So all thanks to her. But there's just so much information on system, and it just goes down like, this is basically a book. It's basically a book of links on system design stuff. Like, it's a good thing we're like still a few weeks away from getting to this, because it's going to take a lot of reading to find the parts of this that are high quality and good to go. Additionally, we'll probably just do a couple of videos about that. So next week is Algos in Detail. Where is week 6? Anyways, so we're going to do more, I think, another round of going through these sort of interview descriptions. We're going to talk about timed practice. Anyways, so there's a lot of stuff still coming. Again, I'm sorry. I am sorry about the special guest. I was probably more excited than anybody else. I thought that was pretty cool. But there we are. 15 minutes back for everybody else. And thank you so much. We will see you next week, I hope. And we'll talk to you soon.